You are welcome back to this channel. So in today's class, we want to use Gaussian elimination method to solve these simultaneous equations involving three unknowns. Now, the first thing that we have to do is to write all these things in a matrix form. Then how do we do that? So let's do that. So write in a matrix form. So coefficients of the unknowns, we're going to write them out and arrange them in a rectangular pattern. So the coefficient of x is 1, for y is minus 4, and for z here is minus 2. So first one we have 2, 1, 2, 3, 2, minus 1. Then you write the unknowns x, y, z. Then is equal to 21, 3, and minus 2. So after doing that one, we need to form what we call an augmented matrix. An augmented matrix. Augmented. So how do we do that? You write this 3 by 3 matrix out. 1, 2, 3, minus 4, 1, 2, minus 2, 2, minus 1. Then you include the answer, that is 21, 3, minus 2. So 21, 3, minus 2. So this is an augmented matrix. So let's call it B. So augmented matrix B. Now, the next thing is that you go to this augmented matrix. The first column here, that is 1, 2, 3. So here, 2, the second element of the first column of the augmented matrix, and the last element of the first column of the first column of augmented matrix, we want them to be equal to 0. Then how do we do that? You go to the second element here of the first column. So the second element is divided by the first element. That would be 2 divided by 1. 2 divided by 1. And 2 divided by 1 is what? 2. So that's to use it to multiply the first row of the augmented matrix. So then we have 1 multiplied by 2, write it here, 2. Minus 4 multiplied by 2, minus 8. Minus 2 multiplied by 2, minus 4. Then 21 multiplied by 2, that is 42. So what we're going to do now is that the value that we got now, you subtract all those elements from the second row of the augmented matrix. So that will be, to write the new matrix. So for this new matrix, you are going to write the first row of the augmented matrix. So we have 1 minus 4. That is, the first row remains. You write it. Now, so I have 2 minus 2, that is 0. 1 minus 8, that is 9. 2 minus 4, that is 6. 3 minus 42, that is minus 39. So after that, we are done with the second row of the new matrix. So let's go to the last element of the first column of the augmented matrix. So here, the last element here is 3. We divide it by the first element, which is 1. That is 3 divided by 1, and that is what? 3. So that 3, we use it to multiply the first row of the augmented matrix. So you have 1 multiplied by 3, that is 3. Minus 4 multiplied by 3, that is minus 12. Minus 2 multiplied by 3, that is minus 6. And 21 multiplied by 3 is what? 63. So you subtract again. We have 3 minus 3, that is 0. 2 minus minus 12, that is 14. Minus 1 minus minus 6, that is 5. Minus 2 minus 63 is minus 65. So now we are done with this new matrix. So here, the next thing here is that you go to the second column of the new matrix. This is the second column. So the last element there, which is 14, we want it to be equal to 0. How do we do that? You now take this 14 divided by the previous element here, which is 9. So that will be 14 divided by 9. So this 14 divided by 9, we multiply it by the second row of the new matrix A. So that would be 0 multiplied by 14 divided by 9. That is 0. 9 multiplied by 14 divided by 9. That is what? 14. 6 multiplied by 14 divided by 9. 6 multiplied by 14 divided by 9. 3 here, 3. 3 here, 2. That is 28 divided by 3. And 28 divided by 3, that is what? 9.33. So this is 9.33. So now minus 33 minus 39 multiplied by 14 divided by 9 minus 39 multiplied by 14 divided by 9. 3 here, 3. 3 here, minus 13. Minus 13 multiplied by 14. That is what? Minus 182. So minus 182 divided by 3 is what? Minus 60.67. So I have minus 60.67. So having got that, so I need another matrix. So the first row remains, the second row remains. So now I would need to work on the third row. So this will be 0 minus 0, 0. 14 minus 14, 0. 5 minus 9.3. That will be minus 4.33. Minus 63 minus minus 60.67. So you do that, I have what? Minus 4.33. So now that is what I need. Now I need to take my 3 by 3 matrix out, which will be 1 minus 4 minus 2 0 9 6 0 0 minus 4.33. Then multiplied by the unknowns x, y, z is equal to, here I have 21 minus 39 minus 4.33. So you can see that I've gotten a triangular matrix. So this is upper triangular matrix. So the next thing that I need to do here is to do the multiplication. So, but I'm starting from the bottom. So back substitution. I want to use back substitution now. So minus 4.33 multiplied by z is what? Minus 4.33 z. That is 0 multiplied by x is 0. 0 multiplied by y is 0. Then minus 4.33 multiplied by z. So I got minus 4.33z is equal to the last element of this column. The column matrix here, that is minus 4.33. So divide both sides by minus 4.33 minus 4.33. So here that means my z is equal to 1. Z is equal to 1. After getting the value of z, so I'll now go to the second row, which is 0, 9, 6. So 0 multiplied by x, that is 0, plus 9 multiplied by y, that is 9y. So 9y, then 6 multiplied by z, that's plus 6z is equal to minus 39. And recall that my z is equal to 1. So that means anywhere I see z, I'm going to put 1 there. So 9y is plus 6 is equal to minus 39. So from here I have 9y is equal to minus 39 minus 6, which is equal to minus 45. So divide both sides by 9. My answer is what? Y is equal to minus 5. So the next thing to do now is to go to the first row of this matrix, and I will have 1 multiplied by x, that is x, minus 4 multiplied by y, that is minus 4y, and minus 2 multiplied by z, that is minus 2z, is equal to 21 here. So my y is equal to minus 5 and z is equal to 1. So let's substitute. So x will be x minus 4 multiplied by minus 5 minus 2 multiplied by 1 is equal to 21. So here I have x minus 4 multiplied by minus 5, that is plus 20. Then minus 2 multiplied by 1 is minus 2 is equal to 21. So from here I have x plus 18 is equal to 21. So after that, I can now make x the subject of the formula. So I have x is equal to 21 minus 18. So x is equal to 3. So the solutions to this equation, that is the unknowns, because that's my unknowns, I use capital X. Let's use capital X to represent it. So I have x, y, z be equal to 3 minus 5 and 1. That is my x is equal to 3, my y is equal to minus 5, and my z is equal to. So that is how to use Gaussian elimination method to solve simultaneous equations involving three unknowns. Till I see you in the next class. Bye bye.